Hi guys, we're going to be vodcasting the first homework of this next unit. That is homework 2.1. This will be the only assignment on this Friday's homework quiz. I wanted you to do problem 2B and also C and E of the second part. So when we look at this reaction, it says determine the standard potential E for a galvanic cell based on the reaction between AgNO3 and Zn written above. So here's the reaction. Okay, so what we have to do first is we have to break it into the oxidation half reaction and the reduction half reaction. So in the oxidation half reaction, Zn is going to Zn2 plus 2 electrons, it's losing them. And in the reduction half reaction, we have Ag plus is going to Ag0, and that's gaining 1 electron for that to happen, and they actually have this already balanced for you there. So what we have to do next is we have to get the values for each of these using the reduction potential chart. The value for zinc is negative 0.76 volts, and the value for silver is 0.80 volts. And we have to plug those into the equation. So E, or commonly E cell, don't worry about that little zero at the top. All that means is this reaction is happening at standard temperature and pressure. Standard temperature is 0 degrees Celsius and standard pressure is 1 atmosphere. Negative E ox plus E reduced. So we are going to plug that in, and that's going to be a negative 0.76 volts plus 0.80, and that's going to be the same as, that's going to be 1.56 volts. So we got a positive E. This is a spontaneous reaction. You would end up with a negative delta G, but they did not ask you to solve for that. Okay, this next one, it says determine the value of the standard free energy change for the reaction between Ag and Cu shown above. So first off, delta G equals negative NFE cell. So what we have to get first is E cell. So let's break this reaction into the half reactions, oxidation and reduction half reaction. The oxidation is going to be Cu goes to Cu2 plus 2 electrons, and the reduction is going to be 1 electron plus Ag positive goes to Ag0. I'm going to look on my chart for Cu. There's 3 Cus. We're going to use the middle value. That's going to be 0.34 volts. And for Ag, it's going to be 0.8 from before. And I know that E cell equals negative E ox plus E reduced, which is negative 0.34 plus 0.80 volts, which is going to be 0.80 minus 0.34, so that should be 0.46, 0.34, equals 0.46 volts. Yeah, that should be right. Let's double check the copper 2 plus. So that's going to be flipped. All right. So now to calculate delta G. Delta G equals negative N. N is the moles of electrons transferred. In this case, it's going to be 2, because the least common multiple between 2 and 1 is 2. F is Faraday's constant. That's 96,500. And E cell is what we calculated, 0.46. And they don't care if you convert it to kilojoules. So the answer is going to come out in joules. It's going to be 2 times 96500 times 0.46 equals negative 88780 joules. So again, the 2 stands for the moles of electrons transferred. It was 2 and it was 1, so 2 were actually transferred. So you can multiply this all by 2, and notice they did that here in the final reaction. If it were 2 and 3, it would be 6. If it were 2 and 2, it would be 2. 96,500 is Faraday's constant, F, which is always going to be 96,500, and 0.46 is the voltage. They want to ask if it's spontaneous or not. So yes, because delta G is less than 0, or because E cell is greater than 0. Both are good examples. Remember, this is written on the board in the classroom. Take care, guys.